Hello and welcome back. In this video we are going to see some examples for finding out the Laplace transform and Laplace inverse transform of some functions. Let's start with Laplace transform. So first example, find the Laplace transform. For working on this example, please keep your table, Laplace transform table, and your properties handy. So first one is 3 plus t cube plus sine pi t. We want to find the Laplace transform of this function. So Laplace transform of 3 plus t cube plus sine pi t. By the first property, by the linearity property, we know that Laplace is linear. So this is same as Laplace of 3 plus Laplace of t cube plus Laplace of sine pi t. This is true by the linearity. Now, using the table, we can say Laplace of 3, which is a constant, is 3 divided by s plus Laplace of t cube. So here the power is 3. So 3 factorial divided by s power, we increase the power by 1, s power 4, plus Laplace of sine pi t. Laplace of sine omega t is omega divided by s square plus omega square. So here our omega is pi, so the Laplace is pi over s square plus pi square. This is our answer. Okay. Let's see some more example. So here in this example we use the property of linearity and the table. The next example can be find the Laplace transform of t square times e power t. E power t times t square. We want to find out the Laplace transform of this function. And if you see your properties shifting carefully, you can directly write down the answer. So here we are going to use the first shifting property, or we call simply it as shifting property. Shifting property says if we have Laplace of e power at ft, then Laplace of f shift by negative a. So this is going to be, first we calculate what is Laplace of t. So observe here, t square, Laplace of t square, Laplace of t square is equal to 2 factorial, which is 2, divided by t cube. We increase the power by 1. Okay. So if we have e power t, we are, so this is s cube, not t. our answer is in terms of s cube. Now we have e power t, so we want to shift this Laplace by -1. So our answer is going to be, we replace s by s minus 1. So this is our answer. Next one, what is Laplace of e power at cosine omega t? So Laplace of e power at cosine omega t. So first we will write down the Laplace of cosine omega t, which is s divided by s square plus omega square. If we have e power at multiplied with, we use the shifting property, and we are going to replace s by s minus a. So our answer will be s minus a divided by s minus a square plus omega square. This is our answer. Okay. Similarly, using our properties and using the table, you can find out the Laplace transform of other functions. Let's discuss about inverse Laplace transform. So next example is to evaluate Laplace inverse of, say, 2s over s square minus 1. We want to find out Laplace inverse of 2s over s square minus 1. If you look at this function carefully, 2s divided by s square minus 1, this function doesn't appear in our table directly. So we need to modify this function little bit so that we can compare it with our table, right? So we are going to use partial fraction here. So method of partial fraction. So what we'll do is, we have 2s divided by s square minus 1. We can factorize our denominator as s minus 1 times s plus 1. All the terms in our denominator are linear. So we'll say, okay, this is a over s minus 1 plus b over s plus 1. Now we want to find out the values of a and b. So first step is, we multiply by the denominator s minus a times s plus 1, and we will get 2s a times a divided by s minus 1 times s minus 1 times s plus 1. So s minus 1 will cancel out. We have a times s plus 1. For the second term, s plus 1 will cancel out and we will have s minus 1. Okay. So now we want to find out the value of a and b. One thing you can do is, you can expand the right hand side and then you can compare the coefficients. Compare the coefficient of s square, s and the constant term. Other thing which is simpler here, much simpler here, is you can choose the value of s. Like if you choose s equal to 1, so this term b times s minus 1 will be 0. You will get 2 equal to 1 plus 1, 2a. So from here, if you divide by 2, you will get your your a is equal to 1. Okay. Similarly, if you choose s equal to negative 1, s plus 1 is equal to 0. So you have negative 2 equal to 0 times a is 0 times plus negative 2 times b. Divide by negative 2 both sides to get the value of b. So b is equal to 1. So what we got is 2s divided by s square minus 1 is equal to 1 over s minus 1 plus 1 over s plus 1. And we wanted to find out Laplace inverse of this function. Since Laplace inverse is linear, this is same as Laplace inverse of 1 over s minus 1 plus Laplace inverse of 1 over s plus 1, which we can easily calculate using our table. So use your table to find out what is Laplace inverse of 1 over s minus 1, and it is e power t. Laplace inverse of 1 over s plus 1 is e power negative t. So this is our answer. Okay. So simply we use the method of partial fraction if the function doesn't match with our table, and then we take the Laplace inverse. Let's see one more example. Okay, so the next example can be if fs is 1 over s minus 1 square times s plus 1, find Laplace inverse of fs. So now if you look at this function carefully, this function is not in our table 1. So we will use our method of partial fraction. So in the denominator we have two terms, s minus 1 square and s plus 1. For the first term, which is square of a linear term, we write partial fraction as a divided by s minus 1 plus b divided by s minus 1 square, and for the term s plus 1 we will write c divided by s plus 1. Next step is we multiply throughout the denominator s minus 1 square times s plus 1, and we will get 1 equal to a times s minus 1 times s plus 1 plus b times s plus 1 plus c times s minus 1 square. Now we want to find out the values of a, b and c, right? So let's substitute s equal to 1 first. So if we substitute s equal to 1, what will we get? This term, the first term will be 0, the last term will be 0, so we will get 1 equal to 2 times b. So value of b is 1/2. Value of b is 1/2. Next we substitute s equal to say -1. If we substitute s equal to -1, the terms which have s plus 1 will be 0. The first term and the second term will be 0. So we will get 1 equal to c times -2 square, which is 4. So our c is equal to 1/4. So 1 and -1 was obvious choice to make two of terms equal to 0. Now if you substitute any other number, now you can choose any number because we already know b and c. So let's choose 0. You can choose any other number also. 0 is easy to calculate, that's why I'm choosing 0. So if we substitute x equal to 0, we have -1 -a plus b plus c. This is what we have. A plus -a plus b plus c equal to 1. We know the value of b and c. So we have -a plus 1/2 plus 1/4 equal to 1. Right? Now you can go ahead and evaluate this. And so what will we get is a equal to, we take the LCM as 4, and we will get a equal to -1/4. So we found out the value of a, b and c. So what we have is our fs is equal to, which was 1/s minus 1 square times s plus 1 is equal to -1/4 1/s minus 1 plus 1/2 1/s plus 1, sorry, s minus 1 square plus 1/4 1/s plus 1. If we want to find out Laplace inverse of this function, so we use the linearity. So Laplace inverse of fs is equal to -1/4, because -1/4 is a constant. You can pull it out. Laplace inverse of 1/s/a, 1/2, you can pull it out. Right? In this step, we are using the property of linearity. Okay, then now we can use our table to find out the Laplace inverse of these functions easily. So we have -1/4 -1/4 Laplace inverse of 1/s minus a is e power t plus 1/2 Laplace inverse of 1 divided by s minus a square. So what is the Laplace inverse of this function? So basically what we are doing is, let me write down it separately. Laplace inverse of 1 over s minus 1 square. So if you look in your table, if you look at your table carefully, 1 over s square, the Laplace inverse of this function is t, right? Now in place of s, you are substituting s minus 1. So here we are using the shifting property. So by the shifting property, you will get e power t times t. So Laplace inverse of 1 over s minus 1 square is equal to e power t times t. We are shifting by 1 unit. Okay, and then we have 1/4 Laplace inverse of s 1 over s plus 1 is e power negative t. So this is how we find out the Laplace and Laplace inverse of functions. And in the next video, we will learn how using Laplace and Laplace inverse we solve the ODEs. Bye bye, take care.